In this video, we're going to have a look at the area of composite shapes. A composite figure or shape can be divided into more than one basic figure. We can find the area of composite shapes using addition of areas or subtraction of areas, and we're going to go through three examples. Firstly, find the area of the shaded region. Let's call the outside shape, shape 1, and the circle that's been cut away, shape 2. Finding the area of shape 1, length times width, or side squared, which equals 100 centimetres squared. Finding the area of shape 2, formula pi r squared. Here, the radius is given as 3 centimetres, equals 9 pi. Now you might like to leave it as 9 pi here and then find the decimal approximation at the end. So the total area, TA, equals area 1, which is the outside shape, take away the circle that's not shaded, area 2. That is 100 take away 9 pi. Using our calculator, 100 take away 9 pi is, rounding to 2 decimal places, 71.73 centimetres squared. That is finding the area of a composite shape using subtraction. The region between two circles is called the annulus, which is Latin for the word ring. Now I've drawn this poorly. I meant to draw the middle circle exactly in the middle because I've shown the centre of the middle circle to be also the centre of the outside circle. So ignore that error. Let's call the outside shape 1 and the middle shape that's been cut away 2. Area 1, pi r squared. Here the radius of the outside circle is 5. Leaving it in terms of pi, we'll have 25 pi. The area of circle 2, pi r squared. So we write the formula. Now the sum, pi times 3 squared, which is 9 pi. The total area, again, is area 1 minus area 2. Here, 25 pi minus 9 pi, exactly 16 pi, or if we're doing the decimal approximation, 16 pi is 50.27 centimetres squared. Lastly, let's find the area using addition. Here I can see that we have two semicircles that would join together and form a full circle. Let's call them together shape 1. And in the middle we have a rectangle, shape 2. The area of shape 1, because it is two semicircles, we'll just call it a circle, pi r squared. If this shape did not have one side, we would then halve pi r squared. Here, the radius is 2 because it's 4 centimetres and 2 centimetres, so we know that that is the centre of the circle, which is 4 pi. The area of shape 2 is length times width, which is 5 by 4, or 20 millimetres squared. I often just tend to leave the units till the end. You could put them as you go along. The total area this time is area 1 plus area 2, which is 4 pi plus 20. Again, using our calculator, 4 pi plus 20 millimetres squared is 32.57 millimetres squared. And that is finding these two, the area of composite shape by subtraction and the area of composite shape by addition. Lastly, I just wanted to go back to the annulus, and you may have seen a shortcut here. We could have gone the area of the annulus is pi times, if we say the larger circle is radius capital R, and the radius of the smaller circle is little r, we could have made a shortcut. In fact, if I do it beside here, without working out the individual areas, the area of an annulus is pi times 5 squared minus 3 squared, which is pi times 25 take away 9, which is 16 pi, and that's what we got down lower. So there is a shortcut, but I tend to use the area of the separate shapes so I don't have to remember a formula.